we're going to use the properties of limits to decide whether the limit exists, and if the limit exists, we're going to find its value. All right, so we're looking at this particular question. And we're going to figure out, as you can see, we have the answer here, but we're going to figure out how we came about that answer. So what we're going to look at, we're going to look at that limit as x approaches infinity. And what we're going to do, since we have a limit going to infinity, we're going to divide everything by the highest x value, or the x value with the highest exponent in the denominator. Okay, so we only look at the denominator for the highest exponent, and sometimes I forget to mention that. I'll say just divide it by the highest exponent, but it's the highest exponent in the denominator. So that means I would have 2x to the fourth divided by x cubed minus 7x divided by x cubed minus 9 divided by x cubed. And then on the bottom I have 3x cubed divided by x cubed, because that is my highest denominator, or highest power in the denominator. So, and now we can reduce what we have. So those x cubes cancel. That x cubed, that becomes just a 2x on top. That x cancels, and that becomes an x squared. So let's go ahead and rewrite this. As our limit approaches positive infinity, I'm left with 2x minus 7 over x squared minus 9 over x cubed all over 3 minus 5 over x squared minus 8 over x cubed. Okay, now at this point we can use our limit rules, and I'm going to write this out. And as you get to know your rules better, you may not necessarily have to write them all out, but I'm going to at least for this example. So I have the limit of 2 of x minus the limit as x approaches infinity of 7 times the limit as x approaches infinity of 1 over x squared. Okay, that comes from the 7 over x squared, minus the limit of 9 as x approaches infinity times the limit as x approaches infinity of 1 over x cubed. That's all going to be divided by the limit as x approaches infinity of 3 minus the limit as x approaches infinity of 5 times the limit as x approaches infinity 1 over x squared minus the limit as x approaches infinity of 8 times the limit as x approaches infinity of 1 over x cubed. Alright, so now we have all these different limits that we can simplify. Okay, so the limit as x approaches infinity of 2x is going to be infinity. The limit of 7 as x approaches infinity is going to be 7, and then the limit of x approaches infinity of 1 over 2 is 0, and we can go ahead, I'm just going to go ahead and write the rest of these out so we can see what we have here. Okay, and so we end up having infinity over 3, which is infinity, so that would be the limit of our problem.